identify the givens and unknowns. What's 5 kilogram ball? That's M1, right? What else is given?
The V1.
Okay, 4 meters per second is what?
V1 of.
Yes, V1 not, right? V1 initial. It's the initial velocity of ball 1. Incidentally, to the right is also the direction of that, right? So it's included. What else?
3 kilograms is N2.
Good. 3 kilograms is M2.
1 meter per second is V2 initial.
Good. And 1 meter per second to the left is V2 initial. And then?
There's still a 5 kilogram, still M1.
Good.
And then 2 meters per second would be V1 final.
Good. That's the velocity of ball 1 after the collision. And then, of course, yes, 5 kilograms and 3 kilograms are still the mass of the respective balls. And what's unknown?
Velocity of V2.
Good. V2F. The V2 final. Okay? So we take our relationship, which is M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final. And I start plugging in. And I say M1 is 5 kilograms and V1 initial is 4 meters per second to the right. Now, what do we need to sign right now? Which way is positive? Good.
Right.
Who do you want to be positive?
Right.
Right? Okay. Right way is positive. Therefore, this 4 meters per second to the right is a positive value. Good. Because even though we're only in one dimension, we have still vectors, so we have to worry about the direction. Okay? And M2 is 3 kilograms. And V up. You guys missed my mistake.
Yes, we did.
I thought I just checked.
Yeah. That's V2 initial. Okay. And what is V2 initial? Negative 1 meter per second.
So you just times those, what would be the units?
Ah, yeah. What are the units for momentum? Well, what is the momentum?
Speed.
Velocity. It's kilogram meters per second, right? It's mass times velocity, so it's kilograms times meters per second. And remember when we talked about the impulse momentum theorem, we said that the units for momentum are kilogram meters per second. The impulse for, the units for impulse is Newton seconds. And what about the two?
They're equal.
They're equal. Because a Newton is a kilogram meter per second squared, right? Okay, so yeah, look back at your notes of that. All right. M1, again, is 5 kilograms. Yeah, but V1 final is,
What was it, -2?
you tell me.
It's going, yeah, it'd be -2.
Who agrees?
But we don't have that one. Wait,
You.
All right, V1 final.
Oh, V1?
Oh,
I agree.
the collision slows the ball. So does that mean it keeps going this way?
Right. If it just slows the ball, does it change its direction?
No, the smaller ball is the one that's going to
It's
change direction.
Well, we don't know that for sure, but we're going to find out. Okay, good. So, yes, this is positive or negative 2 then.
Positive.
Positive 2 meters per second. Plus the mass of 2 is 3 kilograms times the unknown, which is V2 final. Right? Now, here's what you got to remember. Already intuitively you're thinking of whether or not ball 2 changes directions, right?
You don't have to wait.
You're trying to figure that out. don't worry about it. Do the math and let the algebra tell you which direction it's going. When we get our final answer, how are we going to know which direction ball 2 is going?
It's positive or negative.
Exactly, whether it's positive or negative. All right, so what is this quantity? 5 kilograms times 4 meters per second.
20 kilograms.
Good, 20 kilogram meters per second. Plus, this is
Negative 3.
negative 3 kilogram meters per second. And that equals 10 kilogram meters per second plus 3 kilograms times V2 final. Now I'm going to combine all my like terms, just like in algebra. This is algebra, right? This is 20 minus 3 is 17, and then what? Minus 10. So it's 7 kilogram meters per second equals 3 kilograms times V2 final. So now I divide both sides by 3 kilograms. Let me carry this up here. 7 kilogram meters per second equals 3 kilograms times V2 final. So divide both sides by 3 kilograms. And I get V2 final equals what?
2.3 meters per second.
2.3 meters per second.
I mean, how do they keep going the same direction if they don't?
Hold up, let's think about it. Is that positive or negative 2.3?
Positive. Negative. Should be.
Oh, it started off going negative, so it's going direction.
Yeah. It started off going negative in the first direction.
Okay, that makes sense.
Why can't you go positive? Okay, that's going with the slower, bigger ball, except for the faster.
Now, by the way, could it ever be that they pass through each other?
They didn't have to stop. They could hop over this here. Or it's like some type of material like it's osmosis.
Yeah, but then...
Let's say I shoot a bullet through something, moving towards me. I won't make it an animal RPG because it's useless. But let's say I have a baseball moving this way and I shoot a bullet through it. Is it possible that they continue going in the same direction?
Wouldn't it change the math?
They can deform the baseball to where theoretically you can make it to where it didn't change the mass much. You're right. But we can even account for those little pieces of mass. But is it possible for two objects to pass through each other?
Yes.
Yes. So that's why don't worry about what direction. Do the math and then see what the sign tells you. In this case, the sign told us what we expected. Right? It said it's a positive 2.3, which means it's moving to the right, and it's moving faster to the right than the other ball is to the left. And that's what we'd expect from a normal collision.
Can we test, like, do the whole equation with the baseball and the actual speed of a bullet?
Yeah,
See what the answer would
if
be.
they count for it, count the bullet going through it.
We can't do that, but we can do this. Let's say we've got butt and pinky here. Let's see if we can recreate this collision. I need a volunteer to push pinky. I guess you can push pinky.
Thanks, Tom.
Now, I'm going to try and push butt, which is about, 50% heavier than pinky, 4 times as fast as Mason's going to push me. And hopefully we're going to hit each other.
Okay.
We're going to try and keep it in one dimension. Alright? So, why don't you start so I can judge where you're going. Alright. Sorry. We'll try again. I glanced here a little bit. Now, according to this, moving to the right and slows down, what should Pinky do?
To the right.
Go to the right and
Speed up.
be faster than Bud, right? Okay, let's see if we can.
Yes.
Pretty much what happened, right? I mean, again, it was kind of a little bit of a glancing blow. Now let's switch. What do you anticipate will happen if I push Pinky and Mason pushed the Bud and we use the same speeds? If he's going to push Bud about a fourth as fast as I push Pinky,
Let's find that.
what do you think's going to happen?
They're going to stop.
They're going to be close. Stop. Almost stopped. Both rebound.
I don't know.
I can see. No, I don't know. But okay.
Go for it.
I just want to be fast to learn.
All right, let's see.
Right. No.
Right. Right.
It's
Okay. Yeah, they did rebound, but how fast did Pinky rebound compared to Bud? Yeah, a lot faster. So let's work the math out on that and see what happens. Yes. We're moving 2.3 to the right. All right, so in this collision, we had, we'll just keep the same numbers. A 3-kilogram ball moving to the right at 4 meters per second, colliding with a 5-kilogram ball moving to the left at 1 meter per second. And by the way, as in all the other units as well, pictures are always green. And so if after the collision, Bud rebounds at 1 meter per second to the left, or I'm sorry, to the right, then what does Pinky do? Let's see. M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final. M1 is 3 kilograms. V1 initial is positive 4 meters per second, right? Because we're just keeping it right as positive. M2 is 5, and V1, or V2 initial is -1. M1 is 3, and V1 final is unknown. M2 is 5. And M1 final is positive 1 meter per second. So this is 12 kilogram meters per second. This is -5 kilogram meters per second. And that equals 3 kilograms times the unknown, V1 final, plus 5 kilogram meters per second. When I combine like terms, I get what?
2 meters. 2 kilograms.
2 kilograms.
2 kilogram meters per second. Equals 3 kilograms V1 final. So V1 final, according to this math, should have been 0.7 meters per second to the right. So clearly what happened in my collision was we didn't really slow